Greetings, good morning, good afternoon, good evening, grade 12s. I'm not sure what time you are watching this video, but yeah, I truly welcome you and I'm very excited to be continuing with you on this journey of mastering analytical geometry. Okay, so on this lesson, we will be going through a typical exam question paper. A question paper that was written in 2021 May June. It was a national senior certificate paper or metric rewrite. Okay, so we'll be going through the question paper. It's going to be question 3 and question 4 of that particular question paper, and as mentioned, we are doing analytical geometry. On your screen there, you'll see a couple of tips, a couple of things that you need to take into consideration when attempting and solving analytical geometry problems. Okay, take a note of them and you'll see I'll be applying these tips as we go through solving the problems. Okay, analytical geometry, you'll find 2 questions on the question paper, and the marks for the 2 questions, it's roughly about 40 marks. As you can see, with question 3, it was 19 marks, and question 4, it's 20 marks. Sometimes it's 1921, sometimes it's 2020, but yeah, roughly about 40 marks. So it's an important section which I believe you can, if you master it, you can easily pass your paper 2, because that's 20, let me see, that's 40 over 150. So if you master just analytical geometry, that's 26%, 27% of your paper 2 examination, and that is about 13%. So if you just master the analytical geometry, you will just collect 13% of your uh, maths results if you combine paper 1 and paper 2. So just by mastering this, just getting 40 marks on this question paper, that's 13% in the bag for your whole examination. So it's a very important section that you cannot take lightly. Okay, without wasting time, let's look at the problem. Let's start with question 3. And it reads as follows in the diagram: S is given, C 0 and minus 16, and Q 4 minus 8 are the vertices. Okay. Triangle SLQ having LQ perpendicular. I can see that to SQ, SL and SQ are produced to 2 points R and M respectively, such that RM is parallel to LQ. SM is produced at the x-axis at N. Points are 8 and 0. QM is equals to MN, T and P at the y-intercept of RM and LQ respectively. So you've got a bit of information that has been given there. So what is very important for you is to read this and make sure that whatever that they said there is shown on the diagram. If it's not shown, just fill up the diagram. Okay. Now, I can see what's happening here. Those lines are equal. Okay, we can jump straight to question 3.1, which is 2 marks. It says calculate the coordinates of M. So there's your M there. So we want the coordinates. Now you will know that M is the midpoint of point Q, of line Q to N. Why is saying it's a midpoint? Because they told us that QM is equals to MN. It was given to us there. So M is the midpoint, and we know the midpoint formula. So midpoint at M is going to be 4 plus 8 divided by 2, and then minus 8 plus 0 over 2. When you simplify this, 4 plus 8 is going to give you 12. 12 divided by 2, 6. So the coordinates of M is 6. It's 6, and negative 8 over 2 is going to give us negative 4. Okay, so those are the coordinates of M. Easy, 2 marks in the bank. Coordinates M is the midpoint. So you just use the midpoint formula. 3.2, calculate the gradient. And it's for 2 marks. Gradient of what? NS. Where is my N? S. NS is this line here. Okay. So what do we know about the gradient? We know that the gradient, I think I need to fix this. We're looking at the midpoint. We know that the gradient is changing y over changing. So we want the gradient of NS. It's very important to put this subscript just for future references so that you know if you're going to need this in the future, you know what we're looking for. So the gradient we know is changing y over changing x. So NS, it's up to you. You can use point S and point Q to find the gradient, or you can use N and S to find the gradient, or you can use N, S, N. It's up to you because all those 3 points are collinear, meaning they are all on the same point. All right. So I'm going to use S and N. So we're going to have change in Y. So it's going to be minus 16. Let me see. 0 minus 16. So it's 0 plus 16 over 8 minus 0. 16 divided by 8, it's 2. So that's 2 marks there. Okay. Very important to check if your answer makes sense. If you look at this line, you can see this line is an increasing function. It's an increasing line. So it makes sense that my gradient is 2. All right. 3.3 for 2 marks, or we got the 2 marks from the previous question. 3.2 now, 3 marks for 3.3. It says show. What I like about show is because they're already giving you an answer. Show is the same as prove. Prove that the equation of line LQ is given by this. So LQ, where is LQ? So there is my LQ. All right. So we know that when we are looking for an equation of a straight line, it must be in the y equals to mx plus c. Right. So the first thing that you need to find is the gradient. How do we find the gradient? You know, for you to find the gradient, you need 2 points that are passing through that line. I've got Q and L, but unfortunately I don't have the coordinates of L, right? So I can't use that. But you must ask yourself, why on question 3.2 they ask me to prove or to find the gradient of NS? And you will note that line LQ and line LS are perpendicular. They give it to me. They told me even somewhere on the problem statement. I just can't see it now. Yes, perpendicular to SQ. LQ is perpendicular to SQ. So it means the gradient of NS, when I multiply with the gradient of LQ, they're going to give me what? -1. Why? Because perpendicular lines. All right, that's what they told me. It was given. We can also say given. All right, LQ is perpendicular. LQ is perpendicular to NS. All right, so now it's the method of substitution. My MNS 2 times gradient of LQ is equals to -1. Therefore, the gradient of LQ is equals to -1 over 2. All right. Now I need a point to find my y-intercept. Which point am I going to use? I can't use L. I don't have the coordinates there, so I'm going to use Q. So you can use I prefer this formula, y minus y at Q is equals to m into x minus x at Q. Substitute y minus y at Q is -8, so this would be +8. and then my gradient is -1/2, then x, what is my x at q? It's 4, so -4 there. Therefore, when you simplify this, you'll find that the answer is -1/2x. Half of -4 is negative, or half of 4 is going to give me +4. +4 minus 8 is going to give me -6. Okay, because negative half of -4 is going to give me +3. No, +2. +2 minus 8 is going to give you -6, and that's how you got the answer. Yeah, remember that's what we're proving, so we've just shown that. Okay, beautiful stuff. 3.4. Determine the equation of a circle having center O, the origin having center at O, the origin, and also passing through S. Okay, so what they're telling us is that there's a circle with center O, right? And it's passing at S. If it passes at S, it will mean that this will be the radius of that circle. Okay, I'm just gonna draw that imaginary circle that is passing there, that you can see. I'm not gonna focus on the other part on top because I don't have space, but you can see the picture there. All right. So we know that the gradient, the equation of a circle is given by x squared plus y squared is equals to r squared. Since this is a circle with center O in the origin, we know that the a value and the b value is 0 and 0. That's why we use the x squared plus y squared is equals to r squared, right? Now I need to find my r squared. For me to find my r, not my r squared, my r squared or radius, I need to find a point where that circle passes. And they told me that this circle passes through point S. So I'm going to substitute the coordinates of S. My x value there is 0 squared plus my y value is -16 squared. And then 0 plus 16 squared, it's exactly that. 256. So r squared is equals to 256. There's no need to square root this. They didn't want the radius. They wanted the equation of a circle. So I can say, therefore, x squared plus y squared is equals to 256. Okay, beautiful stuff. Now, 3.5, they want us to calculate the coordinates of t. So we've done that. They want us to calculate the coordinates of t for 3 marks. Now, where is t? T is this point here, right? So it's the y. It's a point on the y-axis where we know that x is equal to 0. So the only way, or one of the ways where we can find this, or how we can find this, is for us to find the equation of this line. So we need to find the equation. I'm not saying that's the only way, but for me, what I will do, I will find the equation of that line. And then after finding the equation of that line, which line am I referring to? I'm referring to line RT or TM or RM, however you want to name it. So for me to find those coordinates of t, I need to find the equation of that line, right? So how am I gonna do that? So 3.5. I already know that these two lines are parallel. And what do we know about parallel lines? They have the same gradient. So the gradient of line TM will be the same as the gradient of line LQ. And it was what? -1/2. So what do I need from here? I just need to calculate a point, or I just need to use a point that passes through that line. And remember, I had already found that the coordinates of M is 6 and -4. All right. Now I can go and substitute and say y minus y plus 4 I'm here now. I'm here. But I'm just substituting directly. The coordinates there, I mean, the gradient there is minus 2x minus 6, the x value is 6. Then when I simplify this, I'm going to have 1 minus 2x, and then negative 3, negative 6, negative 3, negative 4. Oh, it's going to give negative times negative give positive. So positive 3 minus 4 is going to give me negative 1. Okay. And then we know if this is the equation of Tm, we know that this C is your y-intercept. Therefore, we can conclude that the coordinates of T is going to be 0 and negative 1. All right. 3.6. 3.6 goes as follows. Determine the ratio LS over RS. Okay, now let's have a look at where is LS. So determine LS over RS. I'm sure you can see the pattern there. This should be familiar. You should be familiar with this when dealing with what is this? Euclidean geometry. The same pattern that you're gonna use on the other side is gonna be that over that. Why are we using this midpoint theorem? Why? Because they told me that these two lines are parallel. And remember, if I were to draw this the way we know it, if you've got parallel lines A, B, C, this is parallel to that, the ratio there is equal, right? Or you can have a similar thing as that over that, that over that. All right, so that's what we are doing. We're just flipping this triangle around. Okay, so now, because the reason why it's really difficult for me to find LS over RS, I don't have the coordinates of R, while I have the coordinates of L. No, I don't have. I only have the coordinates of S, so I can only work on the yellow side, the right-hand side, because that's where I've got the coordinates. All right, so I can say LS over RS is the same as what? It's the same as saying LS, it's the same as saying QS over MS. So now it's just a matter of finding, oh, I need to give a reason. What is the reason there? Midpoint theorem. Or proportionality theorem, sorry. Proportionality theorem. Remember, midpoint theorem is the one that says this length here is half of that. So, but yeah, midpoint proportionality theorem. So I need to find the equation. I mean the length of QS and the length of MS. How do I find them? I'm gonna say QS using distance formula is what? From Q to S, when I have 4 minus 0 squared plus negative 8 plus 16, negative 16, that's equal to 16 squared, and this will give me the square root of 4, the square root of 5. All right. Now I need to find the length of MS or SM. Again, midpoint theorem, no, distance formula. So MS 6 minus 0 squared plus negative 4 minus gonna give me positive 16, and the answer there, MS, going to give me 6 root 5. Therefore, I can come back and substitute that. So the answer there will be LS QS It's 4. Okay, let me not squeeze it. You can come and put it there. You can say LS over RS is the same as QS over MS, which is equals to 4 root 5 over MS 6 root 5. This cancel that, and then 4 divided by 6 will be the same as 1, 2 over 3. Okay, and that's how you conclude this problem. Very important to note the proportionality theorem there. Last question, 3.7. 3.7, which is the last question, it says for 4 marks, so we've done with that. For 4 marks, it says calculate the area of PTNQ. Okay, so let's go to our diagram and identify that. P, T, and Q. All right, so we are dealing with this small quadrilateral, right? We are dealing with that. Okay. If you look at that, I'm gonna tilt it and extract it from the diagram and draw it here so that we can see what's happening. So we've got something like this. All right. So we've got T there. The base there, it's M and T. And then Q there and P there. All right. And we've got the 90 degrees here. So you can see that this is a very special quadrilateral. It's called a trapezium. It brings me back to the properties that I've mentioned there. You must know exactly which formula applies to each type of equation. And there you've got your trapezium, right? Square, rectangular, parallelogram, rhombus, trapezium, and kite. So you need to know the area of a trapezium. The area of a trapezium is area of a trapezium is equals to half the base, which is going to be MT, multiplied by the perpendicular height. Perpendicular height is QM. No, I'm lying. It's going to be half side 1, which is QP, plus side 2, MT, then multiply by the perpendicular height, which is QM. Right, so that's the area of a trapezium. So I need to now, oh man, my pen is acting up now. Oh my goodness, I pressed something on this pen and now it's doing other things. Let's see now. All right, let me undo everything. Okay, so that's my area there. All right, now I need to go and find all this. Need to find QP and to find MT and to find QM. So I'm going to use distance formula. So do I Q to M? I can find it. Did I find it somewhere? Not yet. I need to find Q to M. Is this portion. QM is going to be Sm minus Sq. This one is easy because I already have the length of Qs and Ms. So Sm is what? Sm was 6 square root 5 minus 4 square root 5, and this will give me 2 square root 5. That's Qm. All right, so I found that. I need to find mt. So m to t, so I can use distance formula. Mt equals to, I've got the coordinates of m, I've got the coordinates of t. Remember t there, it's 0 and -1. So mt, I'm gonna have 0 minus 6 squared plus -1 minus plus 4 squared, and this is going to give me 3 square root 5. Right, so I've got mt. Now I need to find qp. So qp is the perpendicular. QP, it's this side here. Now the problem with QP is that I don't have the coordinates of P, but I can find the coordinates of P because I already have an equation of line LQ. Remember, where is my LQ equation? LQ, it was in question 3.3. It's this one. Okay, so I can go and say my Y at Q at P, I'm looking for x is equals to 0 because P is on the y-axis. So x is going to be 0 minus 6. When I simplify that, I'll find that this is 6. So this point here is what? It's 0 and minus 6. Okay, so I can come and find my QP, which is going to give me, or which I will get by using a distance formula again. QP is going to be 0 minus 4 squared, 0 minus 4 squared plus minus 6 minus 8, which is going to be positive 8 squared, and this is going to give me 2 square root 5. Okay, so now that I have all that, I can say my area of trapezium of PTMQ is going to be half of the parallel sides. The parallel sides is QP, so it's 2 square root 5 plus the other side of the parallel lines, MT, which is 3 square root 5, multiplied by the perpendicular height, which is MQ. MQ is 2 square root 5. And when I simplify that, I will find this to give me 25 units squared. And that concludes this problem 3.7 and is at the end of question 3. Okay, take time, pause, go through what I've done, and make sure that you apply the same methodology. And like I said, there are many ways to solve this, but you just need to make sure that you follow the right channels until you get to the right answer. Okay, I hope this makes sense, grade 12s and grade 11s. As mentioned in one of my previous video, question 3 or analytical geometry in your examination will be question 3 and question 4. Question 3 is analytical geometry that you've done in grade 11, and then question 4 is going to be analytical geometry that you are doing in grade 12s. So if you are in grade 11, when you are moving to the next question, just know that this is what you'll be doing in the next year when you are in grade 12s, and that is analytical geometry, also known as circle geometry, right? Okay, let's see what we have here. In the diagram, P minus 3 and 4 is the center of the circle. V is K and 1, and W are endpoints of a diameter. The circle intersects the y-axis at B and C. BCVW is a cyclic quadrilateral. CV is produced to intersect the x-axis at T. So one of the things that I'm going to highlight there is quadrilateral. 4 points or opposite angles of a cyclic quad are supplementary. The exterior angle of a cyclic quad is equal to the interior opposite angles, and yeah, the bow tie theorem if it's the angles in the same segment. So you need to remember this, as much as this is analytical geometry. They can ask questions or they can test your knowledge on other topics. In this case, it looks like they're going to ask us on cyclic on Euclidean geometry. Okay, right, I've got alpha there. So this is not a tangent, it's just a line passing through. Basically, this line is called a secant. It's a line that cuts the circle. It passes through the circle. All right. 4.1 for 5 marks. Oh, okay. So we just start with heavy stuff, 5 marks. Then the radius of the circle is square root 20. So they're telling me that it's square root 20. So we know that if this is a center and this is going to be a radius, this is going to be a radius. They're telling me that this is 10, which means this also equals to 10. All right. Calculate the value of K, the point V. If point V is to the right of point P, clearly show all calculations. Okay. Now, the first thing that you're going to do is to say, I know I'm dealing with center circle. Okay, I'm dealing with circle geometry. And let me see what is given to me. So this, since this is not a circle with center 0 and 0, or center at the origin, I know I need to use this formula. I'm just gonna write it first before I substitute. Y minus B squared is equals to R squared. And then we know that A and B are the coordinates of the mid center. So X minus 3 squared plus Y minus 4 squared is equals to. Now I need to calculate. I need to substitute the radius. I was told that the radius is square root 10. So I can say my radius is square root 10, then squared. Right? Now I've got a problem, but I've got a very nice problem. They want me to find the value of K, and K is the point on the circumference of the circle. So I can go and say, this is my X value, this is my Y value. I can come and substitute the coordinates there. My X value is K, which is what I'm looking for, plus 3 squared plus Y. Y is 1 minus 4 squared, and then this is going to give me 10 because squared will cancel the square root there. Now when I simplify this, this is going to give me K squared plus 6K plus 9. 1 minus 3, it's negative 3 squared plus 9 minus 10 is equals to 0. When I simplify this, K squared plus 6K, 9 plus 9 is 18, 18 minus 10 is 8, so plus 8 equals to 0. Then I can find K there, K there. The bigger number, take the sign of the middle term. I've got 4 and 2. Positive, positive. Therefore, K is equals to minus 2. Or K is equals to 4, negative 4. All right. Now, which one is the right one? The right one, this will guide me. V is to the right of point P. So if the X value at P is minus 3, and then V is on the right hand side, so it means V must have a smaller value. So it means this is not applicable. But the correct answer is K is equals to minus 2. All right. Beautiful stuff. Okay, 4.2. The equation of the circle is given as, okay, so now they're telling me that the equation is given as that. Calculate the length of BC. So they want me to find the length of BC. So we can see that C is the point on the y-axis and B is the point on the y-axis. So automatically we know that the x value there is going to be 0. Even here, the x value is going to be 0. Right? So I just need to find the y values. How do I find the y values? These are point on the circle, so I can use my equation that has been given to me, which is x squared plus 6x plus y squared minus 8y plus minus 8y plus 15 is equals to 0. Okay, so I know that on the circle here at B and at C, the x value there is 0, right? So I'm going to substitute 0 squared plus 6, 0. That's not a beautiful x. 6 times 0 is y squared minus 8y plus 15 equals to 0. This will cancel, so I'll be left with y squared minus 8y plus 15. If I factorize this, y, 5, 3, negative, 2, negative. Therefore, y is equals to 5 or y is equals to 3. So this will be y at B and this will be y at C. So I can say this is 5, this is 3. Now, the question wanted what? Calculate the length of BC. Therefore, BC is going to be 5 minus 3 is equals to 2 units. There's no need to use distance formula. You can see these 2 points are collinear. All right. You can do that, but it's just a waste of time, and you don't have time. Eh? Beautiful. Now, calculate. Okay, we are done. We got our 5 marks. We got our 4 marks. 4.3. If k is equals to minus 2. I love this. The moment they say k is minus 2, and I will also find that k is minus 2, I already know that my answer there is correct. Because it can't be any number except the number that I got. Or if they said k is minus 6, then I was going to be worried. I was going to come back and say, let me come back and check my steps here. But you see, this is already showing me that my answer is correct, right? If k is minus 2, calculate the size of alpha. Okay, so how is that going to help me? I need to find alpha. I can see alpha is an angle of inclination, so I know with angle of inclination, tan of alpha is going to be the gradient of that line, and that line is line, I'm going to call it, you can call it TV, but I don't have the point of T, so I'm going to go to CV. All right, so I need to find the gradient of CV first. So 4.3, I need to find the gradient of CV, which is going to be change in y over change in x. So it's going to be 3. What's happening? 3 minus 1, 0 minus 2, 0 plus 2. And 3 minus 1 is 2, 0 plus 2 is 2, so 2 over 2 is going to give me 1. So the gradient is 1. Therefore, tan of alpha is going to be 1, and we know that tan 1 is equals to 45 degrees. So alpha is equals to 45. All right. Beautiful, beautiful, beautiful. Let's continue. We're still on 4. Oh, this was 4.3.1. Now we're going to go 4.3.2. Now we need to find the angle VWB. Let's look at that. V, where's V? So there's V. Where's W? There's WB. So they want me to find this angle. How can I find this angle? Remember they told me that this is a cyclic quad. All right. So I already know that when I add this angle and this angle, they must give me 180 degrees because opposite angles of a cyclic quad are supplementary. Now the question is, can I find this angle? How can I find this angle? How can I find that? I'm going to try something very interesting. I'm going to say, remember I found that this angle is 45. Now, if you look at this triangle, here you have to be creative. So if that is 45, and we already know that this is going to be 90 because that's the origin. So if that is 45 and that is 90, so this angle is going to be 90 minus 45. So that angle will be TCO is going to be 180 minus 90 minus 45. So this angle here is also going to be 45, right? So these two angles are equal. Now, if that is 45, it means that, and I look at this one is going to be 135 because these are angles on a straight line. If that is 135, then this one is going to be 45. Alternatively, I could have said, now that I found that this is 45 degrees, this angle is the exterior angle of a cyclic quad, which is equal to the interior opposite angle. So that angle will also be equal to that. Okay, so now how do we write it down? We're gonna say, what did you find? We've started by saying in triangle TOC, right? Angle TCO is equal to 45 degrees. And the reason is that some angles of a triangle, they add up to 180. And then therefore we can say angle VWB is the same as TC. What was this? Was this TOC or was this? What was this? TCO. So this was O. TCO. TCO, which is equal to 45 degrees. And the reason for that was that is the exterior angle of a cyclic quad. It's equal to the interior opposite angle. And that is your answer, 45 degrees. All right, beautiful, beautiful, beautiful stuff. Now let's move to 4.4. A new circle is obtained when the given circle is reflected. Okay, yeah, you see now. I'm going to need that. Continue to new diagram. Let's take a screenshot. Yeah, so they say, let's go back to the question. A new circle is obtained when the given circle is reflected about the line y is equals to 1. So what does it mean? It means the line y is equals to 1. It's this line here. It's that line, right? So that's the line y equals to 1. So it means the new circle is reflected about that. Okay. So we know that the x value will still be the same there. So q, the x value will still be minus 3. But the question is, what will be the y value? Now look at this. Remember the k here. Okay, we are looking at the y. Okay, so remember from the origin to this line, it was how many units? It's 4 minus 1, so it's 3 units here. All right. So they will also mean from there to the origin, we must also go 3 units. So what is 1 minus 3? It's going to give you negative 2. So it means our y value there is negative 2. Okay, now I can draw my circle. I'm gonna say my circle will go like this. Right? You'll get the picture. Not, yeah. Actually, this part here is supposed to be the same here, but yeah. Can't draw a perfect circle. But you get the picture. Alright, so it will cut there at V and at somewhere at the point here. And then we've got the coordinates of Q. Alright. Alright, 4.4.1. It says determine the coordinates of Q, the center of the new circle. Oh, beautiful. I already found that. So Q, it's minus 3, minus 1. All right. That is the center of a new circle. 4.4.2, calculate, determine the equation of the new circle in the form that. So they want the equation of that. So that is going to be simple, I hope. So we know that the equation, this is 4.4.2. Remember 4.4.1, the coordinates of Q there is minus 3 and minus 2. Okay, 4.4.2. We know that this is going to be x minus a squared plus x minus b squared is equals to r squared. X, we're going to substitute the coordinates of q, x minus minus plus 3 squared plus x minus minus, it's going to be positive 2, which is equals to r squared. All right. Now the question is, how do I find r squared? How do I find r squared? Remember, this circle, it just reflected about the y is equals to, about the line y is equals to 1. It did not become bigger, it did not shrink, it just shifted, it just reflected. So it means the radius is still the same. And remember, they told me that the radius there of the old circle was square root 10. So even here, the radius will still be the same. Okay, so I can come here and say my radius is 10. Therefore, this will be, know that the root will cancel the square, then the answer there is 10. So my final equation for this question is going to be x plus 3 squared plus y. So this is supposed to be y. I don't know why I use x instead of y. Oh, look at me doing it again. Y and y. Okay. Beautiful, beautiful, beautiful stuff. Lastly, 4.4.3. 4.4.3. It says determine the equation of the lines parallel to the y-axis and passing through the points of intersection of the two circles. Parallel to the y-axis and passing through the points of intersection of the two circles. That is very easy if you're able to draw a sketch like I did. What they're trying to say, the equation of the lines, let me read that again. Equations of the lines drawn parallel to the y-axis. So we know that parallel lines to the y-axis is going to be there, parallel to the y-axis, right? Passing through the points of intersections of the two circles. Now, I've already shown you here that this is where the two circles are going to intersect. The two circles are going to intersect. So it means one equation will pass here, one straight line or one vertical line will pass there, and the other one will pass there. That's where the two circles intersect. Now the question is, what are the x values there? X here is equals to, it passes there at k. K we found it to be -2. And then x value there will be, remember when we were calculating on the previous question on 4.1, they wanted us to find the value of k, and we found the value of k to be -2 and -4. This clearly shows that the other x value here is -4. Because where k is 1, it can either be, where y value is 1 there, k can either be -2 or -4, because this is a circle, right? So those are the two questions, the equation that they wanted. Determine the equations of the lines parallel. So x is equals to -4, x equals to -2, because these lines passes through the point of intersection of the two circles, and we found that to be there and there. And that grade 12 concludes our question from the National Senior Certificate question paper that was written in 2021. It was a very nice question, two beautiful questions. Question 3, we dealt with analytical geometry from grade 11, and question 4, we were introduced or we were tested on analytical geometry for grade 12, or circle geometry or coordinate geometry, however you want to call it. Please go and attempt this problem. Very nice problems, but you just need to know your basics, and I hope you'll do well. Hope to see you in the next lesson. I thank you.